Hello students, today in this video we are going to discuss about radicals, its types and various examples of radicals. Before describing about it, we should know about compounds are formed by combination of radicals. Every compounds are made from radicals, like a two type of radicals. Every compound contains electropositive and electronegative radicals combined, then it gives compound. And when compound dissociated, then it form ions. Both radicals are charged species that form compound, and ions are charged species formed by dissociation of compounds. And here at first we should know about the concept of radicals. That radicals are made up of atoms or group of atoms, and therefore we can define it as a atom or group of atoms having charge on them. Atoms or group of atoms having charge on them, and during chemical reaction that atom or group of atoms behaves like single unit and behaves like single unit during chemical change or chemical reaction are called radicals. It means radicals may be made from atom or group of atoms. And what is important characteristic of that radicals? It carry charge on them and behaves like single unit in chemical change. During chemical change, that radicals behaves like single unit without destruction of its identity. It take part in chemical reaction. Radicals are classified into mainly two groups, and here we describe about types of radicals. Radicals are classified in different types according to some basis. First basis is on the basis of number of atoms present in it. On the basis of number of atoms present in radicals, it is of two types, or radicals are classified into two types. What are these here? At first, simple radical. The radical which carry positive charge on, or simply the radicals which are made up of single atoms, only one atoms, are called simple radicals. And here write the radicals made up of only one atoms are called simple radical. That simple radical contains only one atom. As for example, hydrogen is simple radical. Why? Because it contains only one atom. Oxygen is represented by O minus minus. Nitrogen, it is represented by N minus minus minus. Iron represented by Fe, like a ferrous or ferric form, it does not matter. Here iron contains or ferrous or ferric contains only single atom hydrogen. Here iron, like a gold represented by U plus. So these type of radicals which are made from only single atoms are called simply here these are called simple radicals. Why? Because made up of only one atoms. After that, some radicals are made up of more than one radicals. That type of radicals are called compound radicals. How we define that compound radicals? Second class type of here radical are compound radicals. The radicals having more than one atoms are called compound radicals. In compound radicals, more than one atoms are present. As for example, carbonate, it is represented by CO3 minus minus. Number of charge represent its valency, and here in carbonate one carbon and three oxygen are present. Therefore, it is called compound radical. Hydroxide, OH minus. It contains one oxygen and one hydrogen. Similarly, ammonium, NH4 plus. So these all radicals which are made from more number of atoms, more than one atoms, and having charge on them, then these are called compound radicals. Next type of classification of radicals are on the basis of charge, and here we write on the basis of charge. On the basis of charge, radicals are classified into two types, and here we write it is of two types. And what are these here? The first type of here radicals are electropositive radical. Electropositive radicals are also known as basic radical. Why these are called basic radical? Listen, generally compounds are considered as made from acid or base, acid and base, or neutralization between acid and base. Suppose HCl, hydrochloric acid, NaOH, sodium hydroxide, it is acid and here base, and that gives compound sodium chloride and water. This reaction is called neutralization. And here the part of salt which comes from base are called electropositive or basic radical, which comes from acid are called acidic radical, or simply also we call it electronegative radical. And how we define the radical having positive charge on them. Positive charge on them are called electropositive radical. These are also known by the name of basic radical, and these are also called basic radical. Why it is called basic radicals? Because considered as part of base, or it is considered as come from the part of base. And here we consider some, or we discuss about some example of electropositive radicals. Example of electropositive radicals are here hydrogen. It is represented by H plus, having charge on it, lose electron and form electropositive charge developed, and therefore electropositive radical. Lithium, Li plus. Sodium, Na plus. Potassium, K plus. Ammonium, NH4 plus. And another most important characteristic of electropositive radicals are these are generally metals, or having tendency to lose electron, except ammonium. Ammonium is electropositive radical made up of only non-metals. Nitrogen and hydrogen both are non-metals, but it behaves like electropositive nature. Magnesium, Mg++, number of charge denoted its valency. Calcium, aluminum, Al3+, silver, Ag+, zinc, Zn++, and some electropositive radicals having more than one valency are found in variable oxidation state, like as for example iron. Iron exists in two forms: ferrous, represented by Fe2 plus, iron having two valency, then it is called ferrous. Ferric, Fe3 plus. And generally in these all type of electropositive radical which has more valency, variable valency, its lower valency ends with OUS and higher with IC, like a lead, plumbus, Pb2 plus, plumbic, Pb4 plus. Tin represented by stannous, Sn2 plus, stannic, SN4 plus. Manganese represented by Magnus Mn2 plus, manganic Mn3 plus. Similarly, gold represented by Aurus Au plus, auric Au3 plus. Copper represented by copperus Cu plus, copperic Cu plus plus. Similarly, we can write mercury, mercurous Hg plus, mercuric Hg2 plus, and several more electropositive radicals are found, and that we learn. It is most useful to know about how to write molecular formula of the compound, and then we discuss about electronegative radicals. Second type of radicals are electronegative radicals. Electronegative radicals are also known as acidic radicals. Why these are called acidic radical? Because these are considered as part of acid, and the radical having negative charge on them. It carries negative charge, generally tendency to gain electrons, and therefore electronegative radicals are made from non-metals having negative charge on them. Are called electronegative radical. Electronegative radicals are also known as acidic radicals. These are also called acidic radical because considered as part of acid, and large number of electronegative radicals exist. That here we discuss some important electronegative radicals which are most essential to know molecular formula of compounds. And here example of electronegative radicals are hydroxide. It is compound radical made up of oxygen and hydrogen, OH minus. Chloride, Cl minus. Bromide, Br minus. Iodide, I minus. Similarly, nitrate, NO3 minus. Nitrite, NO2 minus. Hydrogen carbonate, or simply it is also called bicarbonate, HCO3 minus, made up of hydrogen, carbon and 3 oxygen. Bisulfate or hydrogen sulfate, HSO4 minus. Cyanide or nitrile, Cn minus. Other we can write chlorate, ClO3 minus. And more electronegative radicals are oxide, O minus minus. Peroxide, O2 minus minus. Sulfide, S minus minus. Sulfate, SO4 minus minus. Sulfite, SO3 minus minus. Phosphate PO4 3 minus or having 3 valence. Phosphite PO3 minus or 3 minus or minus 3 also we can write. Phosphide P minus minus minus. Carbide C4 minus or minus. Similarly, we can write more number of electronegative radicals which are essential to write molecular formula, like a dichromate Cr2O7 minus, silicate SiO3 minus minus, permanganate MnO4 minus, oxide phosphate, phosphide peroxide, that we write. And here several other more electronegative radicals are found. These are necessary to write molecular formula of the compound. And how we write molecular formula of compound? By using these radicals symbol and valency, we discuss in next video. Thank you.